Okay, for FRQ number 1, we have the table gives values of the twice differentiable function f and its first derivative f prime for selected values of x. Let g be the function defined by g of x equals f of x squared minus x. It's really important on these questions to make sure whether they're asking you about g or f. F is in the table, g is not. You've got to do more work for g. So this first question asks for g prime of 3. So you have to find g prime of x first, which you're going to have to use the chain rule for. So you will take the derivative of this outside part first, and then you have to multiply by the derivative of the inside. So g prime of x is going to be f prime of, leave the stuff on the inside the same, so x squared minus x, times the derivative of the inside, which is 2x minus 1. A lot of you are writing it like this, which is not going to be correct. You got to put parentheses around that, because you got to take this right here has to be the derivative, and the whole derivative has to be multiplied by what you got over here. So you got to have those parentheses there, so make sure you put those. So this is your derivative. You now need to plug in 3. So g prime of 3 is going to be f prime of 3 squared minus 3 times 2 times 3 minus 1. So 3 squared minus 3 is 9 minus 3, so you're getting 6 here. And then 2 times 3 minus 1 is going to give you 5 there. So f prime of 6 we're going to pull from the table. So right here is 6. F prime is 4. So we get 4 times 5, which is 20. So that is our g prime of 3 there. For part B, they tell us we know that g double prime of 0 equals negative 1. They ask us to find the value of f double prime of 0. So this one's a little hard to see where to go with, but we know they're using g double prime of 0. So you're going to have to find g double prime. So g double prime of x, we're going to have to go back up here to this part, and we are taking the derivative of this. This is going to have to be a product rule, because you've got this stuff times something else. It's going to have a chain rule sort of in it as well. So you're going to have f prime of x squared minus x, just leave your f of x alone, times the derivative of 2x minus 1, which is 2, plus 2x minus 1, make sure you got parentheses around that, times the derivative of f prime of x squared minus x. So when we take the derivative here, we've got to use the chain rule. So the derivative of f prime is f double prime of x squared minus 1. Leave the inside parts alone, but you have to multiply by the derivative of that inside part, so 2x minus 1. So make sure you've got parentheses around that there also. So it wants to know the value of f double prime of 0, and it tells us g double prime of 0 equals negative 1. So let's just plug in 0 here. So g double prime of 0 equals f double prime, sorry, that's a single prime right there, f prime of 0 squared minus 0 times 2 plus 2 times 0 minus 1 times f double prime of 0 squared minus 0, 2 times 0 minus 1. So if we clean this up a little bit, this is going to be g double prime of 0. We got f prime of 0 times 2 plus 2 times 0 minus 1 is just going to be a negative 1. This is going to be f double prime of 0, and then another negative 1. So this ends up being here. F prime of 0 we can find from the table. F prime of 0 up here, 0, F prime is going to be 2. So we got 2 times 2. This negative 1 times this negative 1 over here is going to just equal positive 1. So we just got a plus F double prime of 0. So we've got it down to G double prime of 0 equals 4 plus F double prime of 0. F double prime of 0 is what we want to find. It asks us what that value is. Well, they gave us G double prime of 0. It is negative 1. So we can plug in negative 1 right here. And then we just subtract that 4. And we get that F double prime of 0 equals negative 5. So that is our answer for part B. Okay. So, C says, is there a value C for 0 to 3 such that G of C equals 5? Justify your answer. This is an intermediate value theorem. So, in order to use intermediate value theorem, you have to say G is continuous. Up here we know F is twice differentiable. So if F is differentiable and we're plugging in x squared minus x, which is also differentiable, we're going to know that this has to be a continuous function. So to say this in the best possible way, we would say since F is twice differentiable, F is continuous. And therefore, G of x must also be continuous. I can probably live with you just saying G is continuous, but this would be the best way to do it. So now we need to show 5 is between G of 0 and G of 3. So G of 0 we need to find, which is going to be F of 0 squared. Back up to this problem. 0 squared minus 0, which is F of 0. And F of 0, if we look up here, is 4. So we get 4 here. G of 3 is going to be F of 3 squared minus 3, which is F of 6. And F of 6 from the table up here is 7. And so we do see that 5 is between those, so we would say by the intermediate value theorem, since 4 equals F of 0, which is less than 5, less than F of, oh, I should, instead of F of 0 there, let's do G of 0. And let's do here G of 3, which equals 7. Or you could just say 5 is between 4 and 7. That's okay. There is a value C for 0 less than C less than 3, such that G of C equals 5. Okay, so this last part is calculator active. Let me pull up the calculator. So you may use the calculator for it. So it says let H be the function with the derivative given by h prime of x equals 4e to the cosine x, at what value of x in the interval -3 to 0 does the instantaneous rate of change of h equal the average rate of change of f over the interval from -3 to 0? So instantaneous rate of change of h has to equal average rate of change of f. So instantaneous rate of change of h is just the derivative. That gives us the rate of change at a specific point. It has to equal average rate of change of not h, but of f over the interval from -3 to 0. So average rate of change is sloped through the endpoint. So we need to know f of -3 and f of 0, which thankfully we can find from the table. So f of -3 is going to be -5, and f of 0 is going to be 4. So we get -5 and 4. So our points we're dealing with here are -3, -5, and 0, 4. So average rate of change is just a slope between those points. So we're going to do 4 plus 5 over 0 plus 3. We'll get 9 over 3, and we'll get 3. This is my average rate of change of f. And we want to know when this equals instantaneous rate of change of h, which we've already said is the derivative of h. Notice this is already the derivative, so we don't have to take a derivative here. So we're just setting 4e to the cosine x equal to 3. You can kind of solve this part of the way, at least by hand if you want, but we can use the calculator. I think on the key that I did solve it, but let's just do it with the calculator here. So to solve this, we're going to do F2, solve, and we'll just type it in, 4e to the cosine x. Do a comma x before you close that last parentheses there. And so let's hit the green button and enter because it would be better. Oh, I didn't put equals 3. Let's go back. So here, it has to be an equation. That's not an equation. I got to put equals 3 before my comma x. So let's see if it'll work now. And I didn't hit the green button. Alright, so the problem here is that it gives you these crazy answers. There's a couple options of what you can do. Because if you go up here, you can go over, but it's giving you like 2 pi plus stuff here, and it's just kind of difficult to do. So that is why it might be helpful to solve this by hand, or you could use the graph. So if you solve this by hand, you would divide by 4. You would get e to the cosine x equals 3/4. To get rid of an e, we do natural log. And so that would give us cosine x equals natural log of 3/4. And then to get rid of cosine, we do cosine inverse. So x is going to equal cosine inverse of natural log of 3/4. So we can type that in. Cosine inverse of natural log of 3 divided by 4. We'll hit the green button and then enter. And so we're getting 1.8626. So x equals 1.8626 or 1.863 there. Another option you do have if you don't want to solve that by hand, or if you're afraid you're going to mess it up solving it by hand, is this. If you go to y equals, you can type in 4 e to the cosine x there in y1 and type in 3 in y2. So that's just both sides of the equation for e to the cosine x and then 3. And if you graph this, we really only want to know about this from -3 to 0. So I'm going to go to my window, and I'm going to make my x min -3 and my x max 0. And I'm going to graph. And so this point right here where they cross is what we're looking for. To find intersections on this calculator, you're going to do math, F5, which is math, and go down here to intersection. You have to tell it first curve, then it's going to jump down to the other one and say second curve. When it says lower bound, it means the left bound, really. Or on the 84s, it says left bound. But lower bound would be down here somewhere. Upper bound would be to the right of that intersection. And you can see here that you get, oh, I didn't write down my negative, you get 1.8626 here. So that's what you would get here. Oh, that does give you a positive if you do it that way. It's because the calculator is giving you unit circle values instead of giving you principal values. So graph is probably actually the best way to go on that, because 1.8626 is also not on this interval, so it wouldn't make sense for that to be our answer. So the graph is probably the best way to go on this problem, and this will be our answer here.